My name is Miranda and this is lab number 3, circuit and capacitor. The purpose of this lab is to predict the behavior of circuits with resistors in parallel and series. Use multimeters to measure potential differences and current in a circuit, and to understand the behavior of resistors and capacitors. The preview of the main results are that the experimental RC value matched the calculated RC value, and the current in an RC circuit is time-dependent. In the lab, the system is the circuit and the surrounding is everything else. Some fundamental principles used in this lab include Ohm's law, which states that voltage equals current times resistance, and Kirchhoff's law, which states that there's conservation of energy in a circuit, also known as Loop's law, and conservation of current, also known as Node's law. For the first model of the experiment, I constructed the circuit with two 1.5 volt batteries, a 47 ohm resistor and a 100 ohm resistor, and two ammeters. I made the assumption that the resistance of wires and ammeters is negligible, and I predicted the current to be 0.02 A, which matches the actual reading, but if you reverse the ammeter, it would be negative 0.02 A. Then I replaced the ammeter with a voltmeter, and the reading is 3 volt on the voltmeter and 0 A on the ammeter because it is an open circuit and there is no current flowing in the circuit, but in between these sides it shows the potential differences in voltage, which is the total voltage of the battery 3 volt. The graph on the right shows the potential differences between different sites. You can see through my calculation that the delta V total equals to 0, and this coincides with Loop's law. On this slide, it shows how I apply the equation R equals I over delta V to calculate for the new resistances needed for the circuit. Also on the right, it shows what happens to the current when the voltmeter is replaced with an ammeter in parallel with the 100 ohm resistor. So as you can see on the reading, the current increases to 0.06 A because the current is now split at the node, and it will only go through the ammeter because essentially it doesn't have any resistance instead of the node with 100 ohm resistor. For part 2 of the experiment RC circuit, I used 9V battery, 200 MV capacitor, a 10 ohm bulb and a 20 ohm bulb to construct the circuit, and I recorded the time for the capacitor to discharge and charge, and I recorded the voltage and time over time and organized the data in a linearized manner with natural log. I then compiled my data to Excel and then graphed based on my data, and I found out the experimental RC value is 5.3 seconds, while the theoretical RC value is 6 seconds. If I had done this lab in real life, some aspects would be a little different than the simulated computational model. Firstly, the magnitude of the current recorded would be a little smaller because an actual ammeter would have some resistance and it would therefore affect the circuit. And a real battery and capacitor, on the other hand, would take longer to charge than an ideal battery and capacitor because the ideal pair calls for no resistance in each of those components, but in reality, it does have a little resistance, and then it would make the process of charging slower. In conclusion, the conservation of energy in circuit was studied through 2 models in this lab, and some possible sources of error include me starting the stopwatch before starting to charge the capacitor and not stopping right as the capacitor is fully charged or discharged, and this may contribute to a slight imprecision in my data and therefore contribute to the imprecision of the overall data.